So we'll see another very important topic in solid state chemistry. This is the last topic in solid state chemistry. All other portions are deleted. It is very important, the defects. What are the defects? We know the solid having a definite shape, structure, packing and all. If there is any change in this closed packing of crystals, we can call it as defects. So there are different types of defects. We'll see what are the types of defects and examples for this in this video. So defects in solids. So any imperfections in the structure can call as defects. So the main category of defects are point defects, line defects, volume defects. Point defects is the defects if any change in the point, that we know if any constituent particle. Line defects means defects in the entire row or in an entire row. Volume defects is any change in the volume. So you have to study mainly you have only less defects, that are impurity defects. There are different types of defects: impurity defects, stoichiometric difference and non-stoichiometric defects. Sometimes it is pronounced as stoichiometry and some places it is pronounced as stoichiometry. So stoichiometry defect and non-stoichiometric defect will come under point defects, and we'll see it's largely or advancedly. So we'll start with imperfections. So point defects are irregularities or deviations from the ideal arrangement around a point or an atom in a crystalline substance. We know in crystalline substance there are different atoms. If any change in the arrangement, it leads to point defect. Maybe one anion, we know crystals are made up of that are ions which are made up of anion and cations. If any anion missing or such type will come under point defects due to one atom or ion. Any change or irregularity in the arrangement. So the line defect is deviation from ideal arrangement in an entire row of lattice points. For example, if this any imperfection is entire row, we can call it as line defect. So such types of defects are collectively known as crystal defects. So types of point defects. So stoichiometric defects. Stoichiometry or stoichiometry is known as the number of reactants or number of atoms present in a solid. For example, if we take NaCl, there will be certain number of sodium and chloride are there to give an NaCl product. So there are a certain arrangement and certain number of products, number of reactants which gives the product. So if such things are known as stoichiometry. So there are the point defects that do not disturb the stoichiometry of the solid. These are called intrinsic or thermodynamic defects. That is, the stoichiometry of the product or the compound or the solid will not change due to such defects. So there will be no missing of these particles. So basically these are two types: vacancy defect and interstitial defect. So what we'll see what is vacancy defect and what is interstitial defect. This is vacancy defect. If you check this structure, you can see anions are denoted by the letter A plus and cations are A plus, anions are B minus. If you see here, you can see a missing of a cation. So this type of defect is known as vacancy defect. So it's created a vacancy. We'll see the definition. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. So this results in decrease in density of the substance So it will lead to it will change the density. We know in the density it is total number of atoms divided by the total volume. So there will be it creates some change in the density. So it arises due to if the substance heated, sometimes this vacancy will arise. Then interstitial defect. So if one atom decreases, the density also decreases. We'll see what is interstitial defect. If you see this structure, rather than the anion and cation present here, some other anion or some other cation will sit in the interstitial side, the space available, the interstitial sites. Such defects are known as interstitial defects. Due to this interstitial defect, the density will be increases because number of particles are increasing in the structure, so density also increases. So when some constant particles and interstitial site, the crystal said to have interstitial defect. So these ionic solids another types of defects are there, that is FRENKEL defect and SCHOTTKY defect. It is very important. What is my FRENKEL defect? It is shown by ionic solid. The cation, we know in an ionic compound the cation will be smaller. It is dislocated from its normal side to an interstitial side. Such type of defect is known as FRENKEL defect. It creates a vacancy and interstitial. So it is both, vacancy also there, interstitial defect also there. It is also known as dislocation defect. It does not change the density because from one place to another place it is moving, but it is not going to any other place. So there will be no gain or no loss of the substance. It will be exist in the solid itself. So there won't be any density difference. But it occurs in the substance like the anion and cation having large size difference. For example, zinc sulfide, AgCl and AgBr and all. If you take this, there is a large difference between the size of silver and chlorine, silver and bromine and all. So such compounds are known as showing FRENKEL defect. We will see the image of FRENKEL defect. If you see here, from the anion having this, the cation having this position, sodium is anion, it's an image of sodium chloride. So it is having a place, but it leave the space and it create a vacancy defect, and it will move to the interstitial. So but total number of atoms are not differencing, or total number of ions are not differencing. So there won't be any difference. It will move to the interstitial. So it is the mix of vacancy defect and interstitial defect. Such type of defect is known as FRENKEL defect. I will move to the other, that is SCHOTTKY defect. It is also a vacancy defect. So but the atom will be electrically neutral. How come means if we check this one, the number of missing ions will be equal. That is, if two anions missing, the two cations also missing. If you check this image, you can see 1, 2. One cation and one anion missing from here. Here also one cation and one anion are missing. So totally 2 cation and 2 anions are missed from here. So such defect is known as SCHOTTKY defect. It is missing. So vacant space creating in this. So it is missing, so density also decreases. So number of particles decreases, hence density also decreases in this one. Then another type of defect is impurity defect. Sometimes we can see the NaCl will show some yellow color and all, that we'll discuss later. In molten NaCl containing a little amount of strontium chloride, So in this structure, sometimes in the molten state, the Na plus were replaced by strontium. So it occupies the sides of an iron and the other sides remains vacant. So the cationic vacancies thus produced are equal in the number of that of strontium. For example, cadmium chloride and HCl. If you see the image, you will get an idea. That is, sometimes some vacancy, if we heat the NaCl solid, NaCl, it became molten, or if we dissolve it into water, it became molten. So if there is any traces amount of strontium chloride, what will happen is the strontium will occupy the space. Here you can see the blue image. In the occupy the space of the sodium cation, which will create some impurity. Means impurity means other substance or foreign substance uh, rather than the atoms or ions in that compound. So an impurity occupy the space. So such type of impurity is known as interstitial impurity. First a vacancy created, then an impurity will occupy the space. So it is a interstitial impurity. Then we'll move to non-stoichiometric defects. So under stoichiometric defect, we have under point defects we have seen stoichiometric defect and impurity defects and non-stoichiometric defect. It is metal excess defect or metal deficiency defect. It is due to anionic vacancies. Metal excess defect due to anionic vacancies. It will shown by alkali halides such as NaCl, KCl and all. We will see an image. Sometimes if you see sodium chloride, it will show yellow in color, or if you take KCl, it will show, sometimes it show pink color. If you take lithium chloride, it will show blue, lithium chloride pink color, potassium chloride blue color and all. Why it is happening? That is due to the metal excess defect. That is, it is due to anionic vacancies. So alkali halides such as NaCl, KCl and all, if it heated in the atmosphere of sodium vapor, the sodium atoms further deposit on the surface of the crystal. So we know in NaCl there are sodium atom and chloride ions. So chloride ions reacted with the sodium which absorbed in the atmosphere, the surface. So there will be, so for creating the NaCl further, what will happen is the sodium will donate one electron. So this donating electrons will sit in the anionic sites. That is, for example, if you take NaCl, if we heat it within the sodium vapor, so again sodium vapor. So the sodium vapors accumulate in the surface. So that is will be Na form. So there are excess chlorine also, the chlorine in the crystal. So the chlorine in the crystal will move from the site and create a vacancy, and it reacted with further sodium deposited in the surface. So this chloride and sodium will react each other. So for creating more sodium chloride. So this sodium will donate one electron and react with the chloride. So this donating electron will sit in the vacant spaces created by the chloride. So it is due to anionic site. So as a result, the crystal now has excess of sodium. The anionic site occupied by unpaired electrons. These anionic sites occupied by unpaired electrons are known as F centers. Due to these F centers, this NaCl shown the yellow color. Here you can see this in the model of KCl. Here you can see KCl. If more KCl are accumulated in the surface, this chloride will react with this K, excess K, then it will form KCl further here and all. So it will move, or from here it is moved. So the unpaired electron from K will sit in this position. That is an F center. Then it is due to, and it is maybe due to anionic deficiency, or it is due to extra cations. For example, zinc oxide and all. Zinc oxide is in white color in room temperature, so sometimes it turns yellow. So if it heat, its oxygen will leave. This oxygen will remove easily. So excess zinc will be there. So due to this also, the zinc will move to the interstitial sites. Due to that also, metal excess defects are arised. Then next one is metal deficiency. So there are many solids which are difficult to prepare in stoichiometric composition. Less amount of metal as compared to stoichiometric proportion. For example, if we take FeO, this is not one iron and one oxygen is not there. The iron amount is 0.95. So some crystals Fe2 plus cations are missing and lose the positive charge due to sometimes Fe2 plus will convert to Fe3 plus. Such cases also occurs, so it is due to metal deficiency. Such impurities also are there. So mainly the impurities we can classify as point defects, line defects. In point defects, impurity defects, stoichiometric defects and non-stoichiometric defect will come. In stoichiometric defect, SCHOTTKY, FRENKEL, vacancy and interstitial defects, and non-stoichiometric is metal excess and metal deficiency defect. So it is very important topic. Read the textbook well. We'll solve the problems in next class and we'll see some of these examples also in next class. Thank you.